Happy Halloween! Did I scare you? Am I the only one who scared you today? Okay, sorry. If it's for you Friday people, you probably had so much sugar already this morning from your trick-or-treating in the woodlands last night that you're on a sugar down, and so you're not amused by my scary voice at all. For those of you that it is Halloween today, hey, enjoy Halloween. I hope you have a good time. Hope you enjoy the festivities in the woodlands if you are partaking. For those of you if it's November 1st, I hope you did not enjoy the festivities last night and you were home studying for your geometry quiz and you just did awesome on it right now. Alright, so you just had your quiz. We're moving on to 5-3, and our main thing we're going to talk about is really a mid-segment. And what is a mid-segment of a triangle? And what are its properties? So we're going to discover that by using our Geometry Sketchpad. So you should maybe pause right now. If you're really good at a Geometry Sketchpad, you can just pause and do all this stuff on your own. Try to come up with the fill in the blanks for the triangle mid-segment theorem and the mid-segment properties theorem. If you're not very good with Geometry Sketchpad, then perhaps you want to just stick with me and go through some of this with me. Okay, so it says, construct scaling triangle ABC. So I don't really know if this is going to be scaling or not, but I'm just going to guess, and I'm going to start, and I'm just going to try to make my three sides look like they are different lengths. So here is triangle ABC. I'm going to try to label my parts the way this one to the right of these instructions are labeled. So it's A up here at the top, B on the right, C on the left. So I push my capital A, I go A first, B second, C is third. So now I have something that looks like that triangle. Now I'm on step 2. It says construct the midpoint of segment AC. So notice I'm always hitting the arrow button to escape, or you can push the ESC button. So I'm going to highlight my segment AC, and I'm going to go up to the top where it says construct, that menu of construct, and I'm going to construct the midpoint. It's the second one down. So here's my midpoint. If you want to label that M, you have to go back to your letter A. Now it doesn't label it M for you automatically, so you have to double click on that and then just manually change it to capital M. So now I have my midpoint M. Okay, so then it says place your letters in the same order as diagram. We've been doing that. Construct a line M parallel to BC. So we want to have a line go through point M, but we want it parallel to BC. So you select the point that you want the line to go through. You select a segment that you want the line to be parallel to, and then you go up to your construct and you choose the parallel line, and it should make a line go through point M that is parallel to BC. Then it says label the point of intersection with AB, point M. So I need to label this point of intersection right here. So I choose my point, I make sure both of those are highlighted. Now I know my point is on both of those, the line and the line segment there, and I want to label that point N. So I click on that. It's not going to label it N, so I have to double click, and then I can change it manually by typing in N. Okay, now we're all set. We're down here to our discovery part. Number 5. It says measure the length of AN and BN. So how do I do that? Well, in order to measure this length, I have to choose point A and point N. I go up to measure and I go to distance. So here is the length of AN. Then I have to choose point N and point B. I go to measure, I go to distance, and so here is the length of NB. What do you notice? Well, hopefully you notice that they are the same, right? AN is equal to NB. Well, I just told you that M was the midpoint, which means AM is congruent to CM. And then if we drew a line parallel that went through point N, we just discovered that NAN is congruent to NB. So, okay, interesting. But let's look at the triangle mid-segment theorem right here. It says the triangle mid-segment. So this point, this section right here, MN, is called the mid-segment. Okay, and the mid-segment goes through the midpoint of one side of a triangle. So it says a line that contains the midpoint of one side of a triangle and is parallel to another side. So we know that these are parallel. It's parallel to another side, goes through the midpoint of one, it's parallel to another. Then it must pass through the what of the third side. So what do you think this point N was called? It is also a midpoint. If it divided that segment AB into two congruent segments, as you could see in the GSP, if it divided AB into two congruent segments, then that means that this N is also the midpoint of the third side. So your mid-segment goes through the two midpoints, through midpoints on two sides of a triangle, and it is parallel to the third side. Okay, now, more specifically though, let's look at the mid-segment properties theorem. So the mid-segment properties theorem is what we're going to discover here on number 6. It says measure the length of MN and BC. So let's go back to our geometry sketchpad. We now need to measure the length of MN. So I'm going to choose M and N, and I'm going to go to distance. So here's MN. And then I'm going to choose BC, and I'm going to go to distance, and here's BC. Well, what do you notice? Okay, well, if you're not sure, you can adjust. So what do you notice? 4.49, 8.98. What if we try to get somewhere around 4? About 4.05. 4.05, so this length right here, oops, is 4.05. I had it, right? So this right here is 4.05. This right here, okay, whatever, doesn't matter. This right here is 8.10, so how do these relate to each other? Going back here, the segment that joins the midpoints of two sides of a triangle is parallel to the third side. We've already established that, but it's also half as long as the third side. So 4.05, 8.1, that was half as long. So let's use those theorems to find the missing measurements down here in problems 1 through 4. I would say try to pause right now and try them on your own and see how you do. Okay, so let's look at this number 1 right here. We have a 65-degree angle up here. We have a 42-degree angle right here, which means we can then discover this third angle of the triangle, right? Triangle sum property tells us that the three angles of a triangle have a sum of 180 degrees. Well, 65 plus 42 is 107, so this angle right here is 73 degrees if I did my math properly. So now, what else do we do? How can I figure out Z? Well, you should recognize that if this is a double mark, this is a double mark, that means this is the midpoint. And if this is a single mark and this is a single mark, this is the midpoint. And when I connect those midpoints, this right here is known as the mid-segment. And what do we know about the mid-segment? We know it is parallel to the third side. So it goes to the midpoint of one, midpoint of another, therefore it is parallel to this third. So if these are parallel, that means that I have corresponding angles. 73 degrees, and this angle up here must also be 73 degrees because those are corresponding angles. If this is a 42-degree angle right here, this is also a 42-degree angle because these are corresponding angles. Here's my letter F right here, right? Here's my letter F right here. So now I have a 65, 73, 42. Well, guess what? We have a bunch of 5 different triangles that all have the same angle measures. Why do I say that? How do I know? Well, let's look at another set here. This is a midpoint. We already said it has double mark, double mark. Here's triple mark, which means this is also a midpoint, which means this blue segment is also a mid-segment, which means it is also parallel to this right here. So now these are parallel to each other. So now we have new corresponding angles. This is 42 degrees, which means this has to be 42 degrees. right? And where's our other one here? We have 65 degrees here, so this one has to be 65 degrees here, right? I guess I could write that so it's not upside down. So 65 degrees here. Okay, and then we have our third and final. I guess I should do some erasing because that got a little too thick in there. So you could have figured this out maybe right away. Some of you might have seen it right away, but here, this one is parallel to this one, mid-segment, mid-segment, parallel. So what do we have? We have corresponding angles. So if this is 73 degrees, this is 73 degrees right here. And if this was 65 degrees, this is 65 degrees right here. Okay, what does that make Z then? Well, you have to do the math. 42, 65, what's missing in there? 42, 65, what's missing? Well, this is 73. If this is 73 and 65, what's missing? This is 42. If this is 42 and this is, what do we call it, 73? This is 65. So what is Z? Z is 65 degrees. The same thing as it was right here. Whew! Hope you followed that. Okay, over here, number 2, the perimeter of TOP. Well, if this is 10, this is 10. If this is 8, this is 8. So we want the perimeter of TOP. Well, if AR is 20, what is the relationship of OP? It's half of that. So OP must be 10. So 10 plus 8 is 28. Okay, given the diagram, complete the table. So if AB is 12, and BC is 14, and AC is 18. What is ST? So AB lines up with ST, right? If AB is 12, then ST is 6. And then RT is parallel and half the length of BC. So RT must be 7. And then we have RS is half the length of AC. So AC is 9, therefore this is, AC is 18, therefore RS is 9. All right, well, let's go back. If ST is 10, then AB must be 20. If BC is 15, then RT must be 7.5. And if AC is 22, then RS must be half of that, which is 11. Okay, now we just do it algebraically without numbers, but we have algebra as our answer. So if AB is 12x, well, half of 12x, right, divide that by 2, we just get 6x. And then here, if RT is 9x, how do we go backwards? Well, we have to multiply that by 2. So this is 18x. And then our final one, if RS is x plus 1, we have to double it to go backwards here. So that's either 2 times x plus 1, or if you distributed, you could have written 2x plus 2. Okay, a minute and a half for the last one. You might want to pause, do it on your own, come back. But here we have RS is congruent to ST. We have AR is parallel to BS is parallel to CT. If RS equals 12, then what does ST equal? Well, look, this isn't a triangle, but if we just connected it, do we have a triangle now? Sure, and these are midpoints, right? This is the midpoint. So what's going to happen? What do you think is going to happen? If RS is 12, what's ST going to be? It's also going to be 12. If AC is 20, what is AB going to be? Well, hopefully you're saying to yourself 10. If AC is 5x plus 2, then what is B? And BC is 12, what is x? Well, 5x plus 2 should equal twice BC, right? BC, if you double that to get 24, then that's what AC should equal. So we subtract, we get 5x equals 22, therefore x equals 22 divided by 5, or you could change that to a decimal, which would be 4.4, or you could change that to 4 2/5. It's up to you. Right, so x equals 22 fifths, or 4.4, or 4 2/5. So this is something, it's 3 parallels. You can still, though, apply some of those properties. They're not quite the same. but just have a look and ask a teacher if you're confused.